So here we go setting up our triangle. And if you think about it, if two sides are equal in a triangle, that means it's isosceles. That doesn't necessarily mean this is a 45, 45, 90, though. We're not guaranteed about the other one. So actually here, if you draw the loops in, right, we should be, whoops, let's draw it incorrectly here. Try that. Okay, looking for this angle here. This is an appropriate question for the law of sines, right? So sine of 24.67 over this very large number equals sine of b over, once again, this very large number. Although if you carry out the multiplication and all the other work that you would do here, you'll find exactly the same degree measure as angle A. If you think about it, because the two side measures, that means this triangle happens to be isosceles, which means not only are there two sides equal, but back from geometry study, two angles are equal. So technically, they've almost kind of given us that angle simply by giving us the sketch and two sides equal. Okay. Now that we have those two, if we simply add 24.67 to 24.67 and subtract from 180, we end up with angle C here being 130.66 degrees. So obviously my sketch is not to scale, and it was just a place to get started to figure out what's going on. In reality, this thing probably looks a little more like this. So for the side across from the biggest angle, we're expecting a distance or a length even quite a bit bigger than the ones we've got already. So now once we have this one, we're set to use, once again, law of sines. So we have the degree measure here, and now I can figure out the missing side over here, little c, using law of sines one more time. So this time we have the sine of 130.66 degrees all over little c equals either one of the two that are there actually already, because they're identical anyway. And this once again is solved by, of course, good old cross multiplication. And the sine of 24.67 here that is attached to the c, let me write down my multiplication from the other side, sine of 130.66. This sine that's attached to the c is what we're going to actually have to end up dividing by to get the c answer. So this is what we'll calculate to get our answer here. The number I came up with is 4,261.9, as you can see if you're looking at your answer key as the PDF. So that takes care of that particular problem. For number 11, again, if you're thinking about drawing loops to decide if you can figure out a side or an angle, and we carry that through, we don't have any angles at all to work with. So I can't use the law of sines. That's probably an indication that we're probably going to be using law of cosines in this case, which is actually correct. And there were two versions of the law of cosines. One where we were using the cosine of A at the end of a calculation. For this one, and I think I'm just going to randomly go for angle A first. And once I get angle A, then I can actually use law of sines. So if I'm looking for A, version B of this formula, let's make that A, I said, right? I ought to write what I say. Cos of A equals, and this actually was basically the first equation transformed so that cos of A is already by itself. To help me remember this, I remember that the A squared, the matching letter to the cosine I'm looking for, goes here. And then other parts of the top are very Pythagoras-like, b squared plus c squared. And on the bottom was a version of that fudge factor, 2bc. So now if I kind of make my little marks here for where these different letters occur, I can actually start filling numbers in. So it looks like my big calculation will be 37 squared plus 13 squared minus 40 squared all over 2 times 13 times 37, those same two numbers I just worked with. Now here, if you're interested in typing this into the calculator in one big long string, that's all right, but you do want to be careful that down below, you don't simply hit the divide key and divide by 2 and then hit the times directly after, because you're actually not going to be dividing by the next two numbers like you think you might. So it might be helpful to actually calculate this number separately, or after you hit the division on the calculator, be sure to include these three in parentheses so we calculate correctly. When that works out, we end up getting negative 0.064449. At least that's what I wrote down. So again, don't shortcut this and round to 0.1. Your angle reading will be very much off if you do. So what we have equal to that is the cos of angle A. As we've seen in some other problems, if you're looking for an angle measure, you have to actually use the function or the feature inverse cosine and type in the decimal. Again, for us, remember the shortcut is second and the negative sign down below. It'll pull in all those digits with 2 keystrokes instead of the 7, 8, 9, or 10 you would use to type in the number yourself. Plus, it keeps the accuracy going. So that gets us to the, not quite to the end of the question. I think I'll do number 12 on the next video to keep this video short. So once we get this angle, as it turns out, this angle happens to be 93.7 degrees. Once we get that, let's see if I can make something else happen here. No, not what I wanted to do. So after I get that calculation, I can move on and now use the law of sines. I'll have an angle here and I'll have the 40 across the way. That allows me to find angle B down here by using now the law of sines. So let's see if I can slide this up and make a little bit of room here. And work with the law of sines. Since this, of course, is the law of sines, let's be sure we have a sine in there somewhere. Sine of 93.7 over 40, which is the side opposite that angle up above. And then the sine of angle, I said I would look for B, and the number across from B is your lowercase b of 37. Once again, cross multiply. 37 times sine of 93.7 degrees. And that will equal the sine of B times 40. And again, to get the sine of B alone, of course, we're going to be dividing both sides by 40. So basically here is your calculation to come up with the sine of the angle. Once again, that should be less than 1 if you're careful with your calculations. And as it turns out, as you work inverse sine of this answer, your decimal, you should come up with an angle of 67.4 degrees for angle B. Angle C is really quite academic, of course. Simply subtract this total from 180. You should end up with 18.9 degrees to solve this one. And there's a sample of using law of cosines. Cue outro music. Groovy, ain't it?